We will now proceed to melt the lauric acid and benzoic acid mixture. This will have a green label. Be sure to record the mass for both the lauric acid and the benzoic acid. This mass for the lauric acid does not need to be the same mass that was on the original test tube. Pure substances melt at the same temperature regardless of the mass. It is only the lauric acid in this test tube whose mass matters. Once your mixture is completely melted, it is important to stir thoroughly. We want to make sure that the concentration of benzoic acid in the lauric acid is the same throughout. If this is the first time that this particular test tube is being used, this is particularly important. Remember that it will take about 45 seconds for the thermometer to equilibrate to the temperature in the test tube. You can now lower the test tube into room temperature water bath and begin data collection. Now it's time to use our data to find the melting point of the mixture. So what we have here is a cooling curve with a slanted region where we had a liquid and a flatter region where we were forming the solid. We are going to form two tangent lines to these areas by highlighting the straightest portion of the graph. Notice there's a little blip there. That happened when I stopped stirring for a moment to adjust the beaker. I want to make sure that I can highlight the flat region in the bottom Then I'm going to click on the graph, Tools, and apply a curve fit. I want to apply the linear curve. I'm going to do the same thing for this region up here, avoiding the little blip. Now that I've applied the linear curve fit to the tangent lines for the downward slope and the flat portion of the graph, I want to find what this data point is right here. I'm interested in this temperature. However, if I click on the graph at this point, it will automatically give me the temperature of the data that was collected at that particular time. In order to find what this temperature is, I'm going to need to go down to the graph tools and toggle on the interpolate button. This has the 2 points pretty closely overlapped. I can try and adjust this point a little bit to see if I can get the numbers more closely aligned. This looks like it's probably as close as I'm going to get. So I'm going to call the melting point of this mixture 39.3 degrees Celsius. You may notice that I'm leaving off some of the decimal places. In actuality, my thermometer can't calculate all the way out to those decimal places. Also, when I am using my calculations, I'm going to be using a freezing point depression constant for the lauric acid that only has 2 significant figures. So having 3 significant figures in my temperature should not affect my overall results.